Mastercam has a calculator built in to compensate for the flat tip of a spot drill. Spot drills typically have a 90-degree included angle, but do not come to a complete point. Instead, they have a flat at their tip. The size of the flat depends on the spot drill diameter. If the spot drill did come to a point, then the depth of the drilled hole would be the radius of the hole plus the desired chamfer, assuming the required chamfer is 45 degrees. For example, this image here shows the cross-section of a 3/8 spot drill leaving a .025 chamfer on a 1/4 inch hole. Because the spot drill's included angle is 90 degrees, half of this angle is 45 degrees. As a result, the depth of the spot drill should be programmed to the radius of the hole plus the chamfer size. So in this case, of a 1/4 inch hole with a .025 chamfer, the spot drill came to a point. The programmed depth would be 0.15. The drill must first drill 1/8 of an inch for its edge to just touch the edge of the hole, then another 0.025 to leave the required chamfer. The flat size of the spot drill must be taken into account. There are multiple ways to do this. For this lesson, we'll only look at one method. Using this method, the simulator will not show the chamfer on the hole because Mastercam simulator assumes the spot drill is pointed. First, you must be aware of the flat size on a spot drill. This chart shows the standard all spot drills are manufactured to. 3/8 spot drill has a .026 flat. If I go back to the cross section of the 1/4 inch hole with the .025 chamfer, the calculated depth was 0.15, or the radius of the chamfer at the top surface of the part. However, programming this depth will take the drill point 0.026 too deep. As a result, the correct programming depth is 0.15 minus 0.026, which equals 1.24. I'll select the linking parameters and set all my values to absolute. And I'll select the calculator beside the field depth. I'll enter the finished diameter of 5/16 plus 0.05. The 0.05 is the diameter value of the 0.025 radial chamfer. Next, in the tool tip diameter field, I'll enter 0.26 times 2. Because the diameter at the tip is 0.052. I'll enable the radio button to override the depth, and I'll go ahead and exit the depth calculator. I can now enable the flood coolant and accept my drilling selections. I'll now go to the backplot/verify options and ensure that the stock model is enabled as my stock. I'll then close this window and verify the toolpath in the simulator. The simulation looks good, so I'll exit the simulator and save.